Howdy doody, kiddos. Today we're going to talk about some more angle work, and we've been talking about angles that are like on a line or with parallel lines and a transversal. Now we're going to talk about angles in a triangle. So we're going to start just with a quick review of some parallel lines here, and this isn't too bad. So let's take a look at this first opening exercise here. It says 1 is 16x minus 8. And notice how I'm writing on the diagram. Always write on the diagram. And 3 is 14x plus 2. It says solve for x and then find number 2. Okay, well, if I look at 1 and 3, they're both kind of in the top right corner. And if they're in the same position, those are corresponding angles. So I'm just going to take some time here to set those equal to each other. And subtract. I hope everybody's having a good day today. Add 8 to both sides. So now I have 2x is 10. Divide by 2. X is 5. I trust that most of you can do that. All right. Then they want me to find the measure of angle 2. So I need to figure out, is 2 equal to 1 and 3? Wow. It's kind of weird over there. So you know what? Let's start thinking about things, and you could even like turn your paper. Now, I can't really turn the screen here, but if I look at 2 right here, and these arrows, by the way, mean that these lines are parallel, and these arrows mean that these other lines are parallel. Without those there, you couldn't have used the corresponding angle theorem that I just did, but I do know that these are parallel, so I can run with that. So if I look at 2 here, I could also put a 2 right there, because those two 2's would be corresponding angles based on these parallel lines. And this 2 over here on the right is a vertical angle with this number 1 right there. So those things need to be equal. So angle 2 is also a 16x minus 8 angle. So the measure of angle 2 is going to be 16 times 5, take away 8. 16 times 5 is 80. Take away 8 is 72 degrees. And there's the measure of angle 2. You should be able to do that. All right. Now, what about in triangles? There is a rule called the triangle angle sum theorem. And the triangle angle sum theorem says this: the sum of the angles of a triangle add up to 180 degrees. All right. Now, I hate giving you rules where I just say, hey guys, here's a rule. Just, deal with it. That's what it is. So I'm going to do some math magic here with a Post-it. What? So here, bloop, is a triangle, okay? Just your happy run-of-the-mill triangle. I want you to watch what I can do with this triangle. I am going to tear these corners off, bloop. It stuck to me. Tear off this corner, bloop, and then tear off this corner right here. Now, I'm going to move my camera, so I'm sorry if you get dizzy, because I am definitely not a film student here. So I am going to use my camera and say, hey guys, look at these. Here's some little triangle pieces. I'm going to take the perfect corners and I'm going to line them up. And then take this one. And if you look at that, this right here is a straight line. Those 3 corners from the triangle, when I shove them together, they form a straight line. Those are consecutive adjacent supplements, which mean they add to 180. Cool. So one reason that the angles of a triangle add up to 180 is because you can line them up and they form literally a straight line. Cool beans. If you want to stay tuned and stay put at the end of the video, I'll go through another proof as to why that's true. So if you're interested, hang on after the joke and I will go through a quick proof. If not, I accept that. But I am going to go through a proof for you. All right. So I've got the sum of the angles of a triangle add up to 180. Now let's talk about some words from triangles. An equilateral triangle has the word equal right in it. The sides are all equal in length, and the angles are all equal. And if there's 180 degrees in a triangle, if all those angles are equal, 180 divided by 3 is 60 degrees. So those angles all measure an equal measure of 60 degrees. Isosceles triangles have 2 sides that are equal, and the base angles are equal as well. And a scalene triangle has no equal sides or angles. So let's draw some pictures here. An equilateral triangle is something that looks like this. Wow, that's really wiggly. These sides are all equal, and all of these angles are 60 degrees. If I were to draw an isosceles triangle, I can have an isosceles triangle with a tiny top angle where these sides are equal and these base angles are equal. Or you can have isosceles, by the way, that are obtuse, like big wide ones like that, where I have these sides equal and these little angles equal. And then scalene, nothing's equal. Cool beans. All right, moving on. Find the measures of the labeled angles. So now you just got to push everything together. Remember what you know about linear pairs, consecutive adjacent supplements, all the parallel stuff. And then one more thing, the angles of a triangle add up to 180. And by the way, I want to make sure you know that the angles of a triangle add up to 180 is what's called the triangle angle sum theorem. And we're going to reference that, all right? So just remember the name of it. So we have find the measures of the missing labeled angles. Okay, well, I have 1, I have 42, and the 78 is outside. It's not inside the triangle. So the first thing I'm going to do is I'm going to call this angle 2, and then say, you know what? That 2 and that 78, they form a line. That's a linear pair right there. So 180 minus 78 is going to give me 102 degrees. That's angle 2. And then the 42, the 102, and the 1 need to add up to 180. So 102 plus 42 is 44. Nope, 144. Forgot a number there. And 180 minus 144, it's going to be 36 degrees. There's angle 1. All right, let's slide on over here to 2. Ooh, we've got some parallel lines in here, and I've got this kind of bow tie looking thing in X, so I probably have some vertical angles also. So I eventually want 2, but that's outside. Now, one thing that you're going to hear me say a lot throughout the year is don't find what you're told to find. Find whatever you know how to find. All right, so if I look at this and I realize, well, this thing's 94, the first thing my eye is drawn to is that thing next to it, because those would be a linear pair. So 180 minus 94 is going to be 86. So this thing right here is 86. Then if I kind of like turn my head, I notice that with these parallel lines, I could sketch out a letter Z here. Look at this. Isn't this a letter Z? And tucked in the corners of that letter Z, I would have some alternate interiors. So that 57 degrees would also be down there because alternate interiors are equal when lines are parallel. And then this 86 is tucked in the other side of the Z because I have another Z over here. If you can't see it, I'll highlight it in green. This one's a little backwards. Okay. I still don't have angle 2 yet, but you know, I'm getting there. You know what though? I have this one now. Now I have the 2 angles of a triangle, so I can find the third one. So 57 plus 86. Let's see, 7 plus 6 is 13, 13, 14. So those 2 add to 143. 180 minus 143 is going to be 37. All right, so this is 37 degrees right here. And 37 and 2 add up to 180. So 180 minus 37 is 143 degrees. Okay, notice, it's not like I told you to find angle 2, you do this. It's to find angle 2, find some missing stuff and let the dominoes fall and get you an answer, okay? Okay. Here's another one. I got an X. I got some parallels again. So if I want to find, let's see, it says 3 and 4, I got to do a little bit of work. Now, if you don't want to listen to me, feel free to pause the video and then scrub forward. But if you really need to see me go through it, hang on. So now what do I have? I have these parallel lines right here. And you know what? If I follow these parallel lines, I can make a blue Z. So that 46 and that angle 3 would be alternate interiors. Hey, that means 3 is also 46. I mean, that's cool. What else do I see? I see this 94 is next to this thing, and they form a straight line. That's a linear pair. So 180 take away 94 is going to be, what, 86? So this is 86. And then finally, if I want angle 4, I have 2 of the 3 angles of a triangle. They all have to add to 180. 46 plus 86 is going to be 132. Yeah. And then 180, take away 132, is going to be 48. And that's angle 4. There you go. The degree measures of the angles of a triangle. Okay, well, now that we're here, I don't have a picture anymore. You always need a picture, so draw one. I'm going to draw one. So here's a triangle. It doesn't matter what shape you make it, just make a triangle. The degree measures are x, 3x, and 5x minus 54. Find the value of x and classify what kind of triangle it is. Okay, well, I got a bunch of x's. I got the 3 angles of a triangle. The triangle angle sum theorem says they add up to 180. So I'm going to add them up to 180. X, 3x, 5x minus 54, all adds up to 180. So that's x and 3x is 4x. 5 more x would give me 9x. I'm going to add 54 to both sides. And so now I have 9x equals, what's that going to be? 234. Divide by 9. And I'm going to get x equals 26. Okay, so x is 26. Then it says classify what kind of triangle it is. Well, I don't know. Let's plug the x's in and find out. So if I plug those x's in, x is 26. That's one of the angles. 3x would be 3 times 26, which is, let's see, 3 times 6 is 18. 3 times 20 is 60. 60 and 18 is 78. And then 5x minus 54. All right, this one's going to be a little bit tougher to do in my head. 5 times 26, take away 50, not 55, 54. You can obviously do this in a calculator, but my computer calculator is slow, so I'm not going to. 5 times 26 is 130. 130 take away 54 is 76. Okay. So there's the 3 angles of the triangle. One of the nice things about this is you could always check your answer even if you don't have an answer key, because the 3 angles are supposed to add to 180. So 26 plus 78 plus 76, if I add those up, let's see, 20 plus 70 is 160. 6 plus 6 is 12, so I'm at 172 plus 8 more is 180. Yeah, that works out. Well, the 3 angles of the triangle are all different, which means the 3 sides of the triangle are all different. That makes this scalene. And another word we can use to describe this, all of these angles are acute because all of these angles are less than 90. So this is an acute scalene triangle. All right, number 5. In triangle ABC, the measure of B is 21 less than 4 times the measure of A, and C is 1 more than 5 times the measure of A. Find the measure in degrees of each angle. Whew, we can do it. Triangle A, B, C. B is 21 less than 4 times A. Okay, so if I'm comparing B to A is going to be called X. And if B is 21 less than 4 times A, well, 4 times A would be 4X. And 21 less than that would mean I'm taking 21 away. So B is 4X minus 21. C is 1 more than 5 times A. Well, A is X, so 5 times A would be 5X. And then I add 1. I can do that. That's not so bad. And it adds up to 180 because of the triangle angle sum theorem. So 4x minus 21 plus another x plus 5x plus 1 is 180. So I have 10x minus 20 is 180 when I combine everything. Add 20. Divide by 10. I get x equals 20. And it says find the measure in degrees of each angle of ABC. So A is 20 degrees. C is 5 times 20 plus 1. That's 101 degrees. And then B is 4 times 20 minus 21. So 80 minus 21 is going to be 59 degrees. That would be an obtuse scalene triangle because I have an obtuse angle. Okay, so I am done with this. I am going to do the proof after the joke. The joke for the day is, why didn't Dracula have any friends? Why didn't Dracula have any friends? Because he was such a pain in the neck. All right, if you don't want to see a proof, you are free to sign off. But if you want to see a kind of quick proof, hang on. Another reason that we know that the angles in a triangle add up to 180 is because if I draw this triangle ABC, okay, and I number the angles 1, 2, 3, what I can do is I can come here and draw in an extra line. That's called an auxiliary line. And what I can do is when I draw that line, I can say I am purposefully creating a line that's parallel to AC. And the reason that's helpful is because now angle 3 and this thing up here are alternate interiors. So the 3 that's there can be transposed up top. The same with angle 1 over here. Angle 1 and this thing are alternate interiors. So I can bring that up top. And now you have what I did on my desk where I ripped the corners. 1, 2, and 3 all form a line, and those are consecutive. Oops, I can't spell. Consecutive adjacent supplements. So 1, 2, and 3 add up to 180. And I'm done. So I hope everybody's having a great day and you continue to have a great day. Your job right now is to stop watching this video, find the homework that goes with this. I think this is day 7. Oh, who the heck knows anymore? Day 7. Find the day 7 homework and speed through that because you're going to have no trouble. I hope you are all having a wonderful day. You continue having a wonderful day. I'm signing off.